Hello everyone. Myself Dr. A. Victoria-AI12, Assistant Professor, PG and Research Department of Computer Science and Artificial Intelligence, St.Joseph College of Arts and Science, Autonomous, Cuddalore. Today we are going to learn about stack operations, particularly the two main operations called push and pop. These are the fundamental building blocks of working with stacks in computer science. Now let's see, what is a stack? A stack is a linear data structure that follows the principle of last in, first out, also known as LIFO. This means the last element inserted will be the first one to be removed. The two primary operations on a stack are push and pop. Push means we are going to insert an element into a stack. Pop, which deletes an element from this stack. The push operation is used to insert an element into the stack. The new element is always placed on the top of the stack. If the stack is already full and we try to insert another element, then it is called as stack overflow. That is, we won't be able to insert a new element into a stack since the stack is already full. Now let's see the algorithm for push operation. It's very simple. First, we check whether the stack is full. If it is full, then we return null. That is, we won't be able to insert any of the element into the stack. Otherwise, we increment the top pointer by 1. Actually, top is a pointer that indicates the position of the most recently inserted element in the stack. It helps us to keep the track of where the insertion or deletion has taken place. And once the increment is done, then at that position, the new element, that is data, will be placed on the stack and the procedure ends here. Now we'll see the definition of pop operation. Pop refers to the deletion of element from the stack. It removes the element from the top of the stack. And if the stack is empty, then the condition is known as stack underflow. The pop algorithm begins with checking if the stack is empty. If it is empty, we are going to return an error, that is underflow error. Otherwise, we retrieve the element at the top by decrementing the top pointer and then return the deleted element. Here the top is decremented by 1 since we have deleted one of the element from the stack. Now look at an example. We start with an empty stack, and after pushing number 10 into the stack contains 10. Next we push number 20, add 20 on the top of the stack, making the stack 10 and 20. The push operation for 30 happens where the number 30 is inserted at the top of the stack. When we perform pop operation, then the element 30 is removed and the stack becomes 10 and 20. This clearly demonstrates the last in, first out principle that is followed in a stack. Now let's see the application of stack. Stack is used for reversing data, that is reversing strings, arrays or sequence by leveraging the last in, first out strategy that the stack is using. And it is also used for expression evaluation, that is postfix, prefix expressions are efficiently evaluated without the need for parenthesis. And it is also used for parenthesis matching which helps in validating balanced parentheses in expressions during parsing and compilation. And expression conversions, that is, we can convert the expressions that is from infix to prefix, that is if the operator is in between the operand, like x plus y. This is infix since the operator is in between. And if the operator is above, before the operands, then it is prefix. The operator comes before the operands. And if the operator is placed after the operands, then it is postfix. Now the point is that we can convert the infix to prefix, infix to postfix using stack. This is called expression conversion. It is possible only with stack. And it is also used for memory management. That is used internally by the system for function calls, where it stores the local variable and returns the addresses. For backtracking algorithms also, we are using stack, where solving mazes, parsing syntax trees, undo operation, which we are using in Word and other text editors. Now let's summarize the concepts which we have seen in the presentation. The push operations adds an element into the stacks, and before checking the overflow condition, and pop removes the elements from the stack and checks the condition underflow. Both operations are subject to two conditions, that is stack overflow and stack underflow. Overflow in the sense the stack is full, underflow in the sense stack is empty. And we have the stack follows the principle of last in, first out strategy. And once after this operations, we have also seen the real-time applications of the stack in the presentation. I hope you would have understood the concepts clearly. Thank you for listening.